All right, once again, this one is not asking us to integrate anything. We don't have an integration symbol or anything out here, so we're not integrating. We're just doing the partial fraction decomposition. All right, what we have to remember, especially when we see powers on these terms in the denominator, if I got this after fractions were combined, I have to remember like what would have happened before that. So for instance, 16 is the square of 4. If I combine these together, the common denominator is 16, right? So I would have both denominators be 16, and instead of writing 1/4, I would write it as 4/16. And this ends up being 9/16. So in the composition, like after I've combined them, I lost this 4. You know, the 4 goes away and it doesn't appear in the sum. So when I break it apart, I have to account for that. I have to account for the possibility that there could have been just an x plus 2 that when I added the fractions together got gobbled up by the x plus 2 squared. Right? What would be the common denominator here? It would be x plus 2 squared, right? And I would multiply the top of whatever was there before by another x plus 2 if I needed to, you know, if I needed to get a common denominator. All right, but when we do that, even though this is a squared denominator down here, and that's a second power, we still only put a constant up here. Okay, so there's the form of the decomposition. It's not the decomposition yet until we know what A and B are, but this is the form, and this would always happen. If this had been, you know, a 5, then I would have an x plus 2 and x plus 2 squared all the way out to an x plus 2 to the 5th. Because again, what's the common denominator of all these fractions? It's the biggest power on x plus 2. They can all be made to have that denominator. So when we have a repeat, it's called a repeated linear factor. When we have a repeated linear factor, we have to keep in mind that the form of the expansion or the decomposition will need to start with that without a power and build its way up to whatever that power is. All right, LCD is always going to be whatever the denominator is on that left-hand side. All right, when I multiply, I'm just going to get the x plus 8 on the left. On the right, one x plus 2 is going to cancel, and I have a times x plus 2. And on the other one, everything's going to cancel, and I'll have just b. So I have ax plus 2a plus b. All right, and now if you look at what I have, my first equation says, this is 1x, by the way. Ax equals 1x, so a equals 1. That was easy. And then we have 2a plus b, there's no x's there, is equal to that 8. 2a plus b must equal 8. Right? And then since a is 1, that's 2 times 1 plus b equals 8. Subtract 2, we end up with b is equal to 6. So now we know our original expression was equal to a over x plus 2. A is 1, so 1 over x plus 2 plus b plus 6 over x plus 2. And that's where we get the original expression from. And this is, again, called the decomposition of the original expression, the partial fraction decomposition.